Welcome back, everyone, to another presentation up to the time. Today, we are going to be looking at polygons. So what is a polygon? A polygon is a closed shaped figure that has a minimum of 3 sides and 3 vertices. The term poly means many and gon means angle. Thus, polygons have many angles. The perimeter and area of polygon depends upon its types. The classification of polygons is described based on the number of sides and vertices. Below you would see we have 1, 2, 3, 4, 5, 6, 7, 8 polygons. So let's briefly look at these polygons and try to understand something more about them. So the first one is a triangle, which is a 3-sided shape, and all 3 sides have the same angle and the same length of the sides. So each side is going to be 40 millimeters. Each angle is going to be 60 degrees in this triangle. So the triangle is the first member of the polygon family. We move over to the square. The square, all 4 sides are equal. As a matter of fact, all these shapes here are regular polygons. Regular meaning all the sides are equal, and all the sides are going to be equal to 40 millimeters. So this is a square here, and size 40 millimeters, and the angle is 90 degrees inside at the vertice. This is a pentagon here, a 5-sided shape. The angle that goes to make this 5-sided shape is 108 degrees at each vertice. All right. This is a hexagon, 6-sided shape. The angle that goes to make these is 120. This is a heptagon now, 7 sides. So let's come here, 1, 2, 3, 4, 5, 6, 7 sides. The angle is 129. Okay. Let's move on. So let's come down here. The octagon has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, each at 40 mil, and the angle inside is 135 degrees. Let's now go on to the nonagon, which has 9 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides, and the angle inside is 140 degrees. Let's move on to our last polygon, which is a decagon. This has 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the angle is 144 degrees on the inside. The decagon, 10 sides. Now that we have gotten that out of the way, what is our task today? Let's come over here to the right side of the screen. What I've done is I've placed the task on the inside of the AutoCAD screen, and I think this is better so that I would have to split these screens up here, and everyone would be able to see all of my commands up here without me splitting the screen, so that while I'm explaining this, you'll be able to see things clear and understand better, especially when I'm going to be using the shortcut keys or using any keys on the menu at the top. It makes it easier. There, I want to show everyone at home how I insert my reference images into AutoCAD. Before I used to split the screen like this, and I would have my reference on the right hand side. I found that by splitting the screen, you're not able to access all of your menus at the top properly, and it can be a bit frustrating. So what I do now is I come up here to insert, and I go to attach. Attach here, insert references to external files such as other drawings, raster images, and underlays. So I click right here and I look for, I go into my folder, just view thumbnails, and I look for an image that I want to reference. So say I wanted a question that I'm doing, instruction, okay. And I click and I hit enter. Click where I want it to be, a point, and then I hit enter. Now, if this is a bit too small and you want to increase, I just grab the size and I just pull it, and you can size it just by grabbing the size, and you can move it by just typing M to move, and you can set it to however you are comfortable. So that there is my question. Also, if you find that this is too bright, there are options here that you can turn down the brightness. It just adjusts the fade and you can see everything, right? So that's basically how I insert my reference images now. Thank you. So the first thing I'm going to be doing is I'm going to be doing this problem here. Let me just highlight the problem. This one here is the first one that I'm going to be doing. A regular pentagon has size of 40 mil. Construct the regular pentagon. Enlarge the regular pentagon to a similar figure with linear measurements of its sides in the ratio of 3 to 5. So that's what we're going to be doing first. So we're going to be doing this from scratch. And this construction of a pentagon is based off of the line measurement. And the line measurement is 40 mil. So this is the line method technique I'll be using to create a regular pentagon. And then I'm going to increase the scale from 3 to 5. So that means the pentagon is going to be currently at 3, and then it's going to be increased to a ratio of 5, 3 to 5. Let's go ahead and get this started. So the first thing I'm going to do is go here, grab my construction lines and hit L for line. And I'm going to come somewhere over here, put on my ortho by pressing F8. That means my ortho is on, so I can draw perpendicular. So my distance is 40 mil. That's my distance there. And let's zoom in around here so they have enough space to work with. A, B. All right. Let me just move these slightly off so that they won't be touching. Yeah. Okay, good. I think I'm at a good spot. I don't have to do much zooming. All right, 40 mil. Just dimension here so that everyone can see that it starts with 40 mil. Now, what's the strategy? I now need to create a 45-degree line at point A, and then create a 60-degree line at point B. I'm going to create this 45-degree line. That's my 45-degree there, and my 60-degree is here. Okay, now the 60-degree goes in this direction. I want it on the opposite side. I'll just mirror. Am I mirror? Erase source object, yes. What I'm going to do is I'm going to place my 60 degrees in here and my 45 degrees so that everyone can see that's 45 degrees and that's 60 degrees in there. Now, what am I going to do now? I need to divide A and B into half. So this is the halfway point here. So I'm going to draw a line. Let me just hover. It says midpoint. Now I'm going to divide the line A and B into half by projecting this line upward. So this divides the line. I'm also going to put that line into my center layer. Okay. Now, what am I looking for? I'm looking for the points where this center line interacts with A and also where the center line interacts with B. So let me identify these points. That's a point here, and that's the point there. So at these points, what I'm going to do is I'm just going to pull a line out and call these points 4 and 6 respectively. That's points 4 and this is 0.6 here. That's 0.4 and that's 0.6. Now the shape we want to create is a 5-sided shape. So we need to get to 5, but we already know 4 and we know 6, the distance between 4 and 6. So in order for us to get to 5, we need to bisect the distance between 4 and 6. Bisecting just means finding the midpoint, and wherever the midpoint is, that's where 0.5 would be. So let me do that. I'm going to draw a line between 6 and 4. That's that, and that's the midpoint here. And I'm going to draw a line from the midpoint, bisecting that, and I'm just going to project it out left and right. And I'm going to put that into my midpoint there. So we have found 0.5. Let me just place a point here. And I'm going to bring down this to there. And that would be our 0.5. Okay, so far so good. So what do we do at 0.5 now? At 0.5, we create a circle. So 0.5 is the axis of our circle, and we open our circle to point A or to point B. No matter what, they should both touch the same thing. The circle should touch both A and B. Now, after we have done that, we're going to soon be finished with this problem. Now we need to go and create another circle to capture a distance of 40 mil, because each side of this pentagon needs to be 40 millimeters. So I'm going to come here at A and open up a circle to B, which is a radius of 40 mil. And then I'm going to move with this circle to plot in my other points. So the first thing is, I can see that there's a point here already. That is a point. As this circle touches this outer circle, as the 40 mil touches the circle that was created from 5. So now I'm going to move this over to B. And here, this intersection is another point. So I place a point there. Now, what else do I need to do? I can do this, at this position here, and look at what we see. We realize that this is a bit tricky. This comes here, and it creates a point there. And if I move this over to here, we realize it creates a point right here. So which point is it? Now, when these 2 points, one occurs here and one occurs here, what we do is we put it in the middle. So the real point comes directly in line of the center line interacting with the bigger circle, the circle that was created at axis 5. So we're just going to place our point here. So we don't really need these points. Yeah, so I can delete those, and we will use the center as our final point. Now, let's connect. So we have A, we have B, and now we have B going to C, C going to D, D going to E, and E returning to A. Okay. Now, let me place these into an outline there. So I'm going to match drop. I made a match drop, grab that. Okay, so that there is our regular pentagon of size 40. Now, we need to increase this. So what I'm going to do is I'm going to leave this to the side as a construction. Let's just leave it there, and then I'm just going to copy thing out over to here. And I'm going to remove everything but the pentagon shape. So this is our shape here. Final look. I'm going to label the other points that were just created, A, B, C, E, E. Okay? So that's A, B, C, D, E. Now, I'm going to increase this to a scale ratio of 3 to 5. What does that mean? That means currently this shape is in a ratio of 3. So this shape is at 3. So I put here shape at 3, shape at 3, and needs to be increased by. That's a shape at 3 and it needs to be increased to 5. How are we going to go about doing that? Well, first, we need to create a construction line from point A, and we need to divide that construction line into 8 segments. Why are we going to be using 8? Because we have a ratio of 3 to 5, and what we need to do is add 3 plus 5, and we get 8. So 8 is our number of divisions. So I will put here div, and I'll put 8 here, right? So that's how we resolve that. That's clear. Insert that now. So we create a construction line at A, and like I said, it's going to be a construction line at A. I'm going to take off the ortho because it can be any angle going downward away from B. So I just randomly choose a number. Now I'm going to divide this line here into 8 pieces. 8, those are my 8 divisions, right? 1, 2, 3, 4, 5, 6, 7, and then the last point is 8. And I can just do this so that everyone will see the division. Now, at points 3 and points 5, I'm going to highlight. So I'm going to find where point 3 is. So this is point 1, 2, 3. That is point 3 there. And then what else? We need point 5. How do we get from 3 to 5? This is what we need to do now. So the shape is going to be at 3. And we need to go from 3 to 5. So we go 3, 1, 2, 3. Right? We count 1, 2, 3, 4, 5 to get to that point, to get to point 5. Right? And to get here to point 3, we count 1, 2, 3. So that goes 1, 2, 3. All right. I hope everyone understands how we set up this ratio on our construction line. Now, so I'm going to carry this down here to 5. Now we need to make the shape AB3. So I'm going to attach 3 to B. What does that mean? Is now the shape is at 3. Or at least the distance AB is at 3. Let us now extend this line outward to some random distance. And I'm going to copy 3 and bring it down, copy the line that is at 3 and bring it down to 5 and snap it into this node point and then extend this line all the way to here. So it comes all the way to here, so I can drag that back here because that's the full length that I need, right? That is now our new B. This is now B that is at 5. So this will be called B prime. All our new points will be called primes from here on. So that is B prime that is at 5. Now, how are we going to get to C prime, D prime, and E prime? Let's create construction lines from A going to C, A going to D, and we don't need to create A going to E because A goes to E naturally. We don't need to create the line there. It's already there. Now, what are we going to do? We are going to copy the distance. We are going to copy this line from B to B prime, and we're going to fill it. The line AC at B, and that is where our new C prime point would be, up here. We're going to copy this to here, and let's call it C prime. That's C prime. Now let's do the same thing. The line C to D, you're going to copy, snap it, and place it here at C. And now we're going to fill it. This construction line there, and that's where our point D is. So that's our point D. Let's call that up. Well, sorry, that's our point D prime. And now we're going to do the same with the line E to D. Copy this. I'm going to snap in and place it here. And then I'm going to fill it. This line A to E till it creates our E prime. Then once that is done, I'm going to copy this and call it E prime. All right. So this is the new shape. This is the new shape. What I would do is I'm going to hatch inside here. Reason why you can't see it is because I had my hatch layer turned off. So that is the increase there. And I'm going to increase the size of these numbers here to make it slightly larger so we can actually see the ratio in the numbers. Yep. So now the question has been answered. I have created my regular pentagon. So I can put here regular pentagon 40 mil. And I'll put here regular pentagon 40 mil increase the ratio to 3 to 5. Increase, let me see what's the language they use. Okay, regular pentagon 40 mil increase the ratio 3 to 5. I think that looks good. We have everything labeled. So now what I can do is I can give you the distance of the new A to B prime. And let us see that now. DIM. What is this distance? The new distance here is 106.7. So we move 40 to 106.67. All right. That there is the end of that question. That question is done. Think what I can do. So I can call this construction. But anyone seeing this, they would know. This is my construction. Construction of pentagon. This is the finished product here. Now let us move on to the next pentagon question. So this one here we can actually get rid of because it's finished. But I would not get rid of it. I will still use it in the end when I'm recapping. Now, let's go on to this one where it says, draw a line AB 150 mil long. Divide the line AB geometrically into 7 equal divisions. Draw a circle using 5 parts of the line AB as the diameter. Construct the largest regular pentagon that can be fitted into the circle. So this next way of creating a pentagon is by using a circle method. Yes, they say draw a line AB 150 mil, but that same line, they want you to divide first thing into 7 pieces. So you divide this into 7 pieces, you get some sort of a marks there. But then they ask you to draw a circle using 5 parts of the line AB as the diameter. So this is going to be done using the circle method. So this is the circle method, circle. That's the circle method here. And how do we know? Because we need to draw a circle using 5 parts, the stress on that, 5 parts of the line AB as the diameter. So when you see diameter and you see circle, we know we have to draw a circle. And then lastly, we need to construct the largest pentagon that can be fit within this circle. So there are so many clues here letting us know that we are going to be constructing a pentagon using the circle method. How do we do that? Okay, let's get to it now. So the first thing is we need to draw a line AB 150 mil. So I think I can come here, draw 150 mil. Yeah, that looks good. And that's AB. Let me just grab A from here and copy it over A, and then you call that B. All right, that's A to B, 150 mil. Now what they ask us to do is to divide this line into 7 equal parts. Now the way to divide a line, I'm going to show you 2 ways. We can do it this way, which is the original way. So you just grab a line and you create your random distance. Whatever distance you want, that's up to you. So this distance could be here, or it could be all down here. I just pull it down to show people at home that this was a random distance. What is this line called? This line is called a construction line. So let me label this line so that people would know that this is a construction line. All right, construction line, any length. Right. Construction line, any length. Cool. Now what we're going to do is we're going to divide this into 7. DIV 7. That's into 7. And because the whole line AB needs to be divided into 7, this last point goes up to B. And then what we're going to do, we're going to copy in all of these points here so that we can get our division on the actual real line rather than the construction line. Trim off here, and we can then try. So this is the real line AB. Let me just put it into the outline. And this is the construction line. So just to make it clear, we call that construction line. Let me just bring this down here. Okay. We call it real line. Real line. Okay. Let me put in the number of divisions. 1. 3, 4, 5, 6, 7. 7, right? 1, 2, 3, 4, 5, 6, 7. So I've drawn the line AB, 150 mil long, and I've divided AB geometrically into 7 equal divisions. So I've done B and I've done A. Now they say draw a circle using 5 parts of the line AB as your diameter. So I now go to the 5th part, which is here. So 1, 2, 3, 4, 5. So this point here, let's put a point here. This becomes now the diameter of our circle. All right. Let's look and see what this distance is. This distance from A to B is 107, and that becomes the diameter of the circle. So how can we pitch a circle from here? I'm going to break this line at this exact point by pressing BR and then pulling it back to here. So I can make this line part of the construction, and I can make this line now my real line, or I can just keep these as both my outline. But I want to distinguish this, so I'm going to put this line into, let's put it into hatch, so that we know this is where we're going to, this is the line we're going to be using to create our circle that we're going to put our pentagon inside. So let me create a circle here. I found the center, and that there is my circle. Cool. All right. Now we need to create a pentagon inside here. So it's interesting that they ask us to divide this into 5 pieces. At this to use the 5 pieces out of the 7. Because in order for us to create a pentagon within a circle, we need to divide the diameter into 5 pieces. So by doing that initial step, this step has been taken care of. So we have our, let's call here A to C. A to C must be divided into 5 pieces. So let's just call this point here A to C, which we would know is the actual diameter of the circle, right? This is the diameter of the circle, and that is something like 107.14. So let's divide A to C into 5 pieces. It has already been done. 1, 2, 3, 4, 5. Cool. Now we're going to be using points 2. So let's put a point here. We're going to be using that to create the construction. But first, before we do that, we need to open up a compass at A and open it to the entire distance of A to C. And we create that. And then we're going to do the same thing at point C. So you can copy that. So you can copy this over to point C, this same circle. And yeah. Now look at what happens. It interacts or intersects up here, and it intersects below down here. Now I'm interested in the intersection here, so I'll place a point here, and I'm going to randomly call that point S. S for the sun. The sun directly above the earth. So if this is the earth here, this point here is the sun. So I remember this. That's why I labeled it S. Okay, so I can get rid of these instructions. So I've trimmed that. So this is my point S here that I've just installed. Like I said, that is the sun directly above the earth, this being the earth here. Now what happens to the sun? The sun needs to beam its light down through 2. Then it needs to extend that light right through as it pierces the surface. Not only hits the outer side of the surface, but goes through to the inside and then back to the outside. So that's the sunlight beam going through 2. And why did it go through 2? Because 2, the distance A to point 2, somehow magically when the sun goes, the sunlight or the light or the line from S goes through this point 2 and it hits this end piece, and it hits this side of the circle. That distance from here, just draw it, the distance from here at this new point, the A, is the required length of our pentagon. So we need that length to go around from here to there and plot this line and then do the same thing to get the rest of the pentagon. All right, and then you will come up here, like here, so, and then that would come back into there. You get the drift. So let's label this point here now. So let's call this point, call it point R. That's point R, and that is required distance. So A to R, it's not A, it's not R. I'm going to put it in outline because that now becomes our required distance, and we're going to go around. So I'm going to open up a circle at A that touches R, right? And if it touches R and it interacts with this circle here, let's look at the other side. It's going to interact here. So that's going to be a point. And we can call that point P. That's point P. We can draw a line from A to P. And now we can move the circle. So we can move the circle to P and see where else it interacts. And it interacts here. So you can call that point Q. And at this point, just randomly calling letters. So don't be surprised if any letter comes in here, right? That's Q. Capitals. So we got A, P, Q, R. Now let's move this circle and bring it back to R and see where we go from here. So it interacts right here. So we got A, P, Q, R. Let's call this one T. So we connect the line from R to T into my outline. And there's only one more line to go, which is the line between T and Q. And that is our regular pentagon using the circle method, all right? That is it there. So our pentagon is A to R, R to T, T to Q, and Q to P, and P back to A. Let's look at the size now of let's look at the dimensional side, just so that we know a little more information about this. And that comes in at 62.94, right? So I'm just going to dimension the circle and then dimension it. So if someone wanted to create this, they would just need to know the circle and follow this construction technique, and you will get everything done. So let me label what I've done here. So this is a regular pentagon created by using a circle method, right? By using the circle method. We place the diameter of the circle is 107.14 mm. This is a regular pentagon using the line method. The line is line A to B. A to B is 40 mil. So I think that we have done everything. I'm just organizing my layers now, placing my notes into the text layer. My construction lines are on my construction layer. My outline is in my outline layer, right? My outlines. So let me just recap to make sure that I've done everything for this question. Draw a line A to B, 150 mil. So that's the line here. So let me dimension that. A to B is 150 mil. I can get some marks of that there. This word is on. It's line A to B. And divide the line A to B geometrically into 7 equal divisions. That's done. Draw a circle using 5 parts of the line A to B as diameter. That was done also. Construct the largest regular pentagon that can be fitted into the same circle. And that is done. Okay, this first one here. A regular pentagon has sides 40 mil. Construct the regular pentagon. That was done using the line method. Enlarge the regular pentagon to a similar figure with linear measurements of its sides in the ratio of 3 to 5. That was done over here. So what I can do now is I can place these all into a title sheet. 0. And that here brings us to the end. Let me just set this up properly. There's that. And that brings us to the end of this presentation. I hope everyone learned something new from this short demonstration. I would like to encourage everyone to practice. First thing, learn the polygons and learn the angles inside that go together to create the actual polygon. So turn off the hatch so we can all see. Learn these. Learn where the sides of a shape is and where the vertices of the shape is, so that these terms you'll be familiar with. And lastly, practice, practice, practice. Please share this information with others so that they would also understand. And lastly, like and share, like and subscribe to the channel. I am out.